Have you ever wondered how your favorite video game character moves so smoothly? Or how computer graphics are designed so precisely? Well, the secret lies in a fundamental concept called circular measure. It's a cornerstone in computer science, underpinning various algorithms, graphics, and computational geometry principles. The star of this show is the radian, the primary unit of circular measure. It's defined as the angle subtended when the arc length equals the radius of the circle. So as you can see, the radian is not just a random unit but a powerful tool in the world of computer science. Now you might be wondering, how does one convert between degrees and radians, the two common units of circular measure? Well, it's surprisingly straightforward. The conversion factor hinges on a simple equation. Pi radians equals 180 degrees. That's right, pi rad equals 180 degree. To put this into practice, let's consider an example. Say we want to convert 60 degrees into radians. We start by multiplying 60 degrees by the ratio of pi radians over 180 degrees. This simplifies to pi over 3 radians. So, 60 degrees is equivalent to pi over 3 radians. Remember, understanding this conversion is crucial in computer science, where you'll often need to switch between these two units when working with angles. And just like that, you've cracked the conversion code, making it easier to work with angles in computer science. But how does circular measure relate to the real world, or in our case, the virtual world of computer science? Let's take a closer look. We've discussed the radian, a unit of circular measure, but how do we use it? Well, one of its applications is in calculating the arc length of a circle. The arc length is directly proportional to the angle in radians and the radius of the circle. So the formula for arc length is S equals R times theta. Let's say we have a circle with a radius of 5 units and a central angle of 1/4 pi radians. Using our formula, the arc length will be 5 times 1/4 pi or 1¼ pi units. Similarly, we can calculate the area of a sector of a circle using the formula A equals half R squared times theta. So with these formulae at your fingertips, you can now calculate distances and areas in your virtual projects with ease. Let's now delve into how circular measure finds its application in the field of computer science. From creating smooth animations and defining shapes in graphics to defining angles in computer-aided design, circular measure is everywhere. It's even integral to signal processing algorithms in fields like audio and image processing. So whether we're rotating an object in a game or designing a 3D model, circular measure is at play. Indeed, circular measure is a fundamental tool that shapes the digital world as we know it.